let's talk about averages and moving averages. Got to get a good pen color. There we go. All right. The average or mean of a collection of values, just like average cost, we use the bar notation for an average or mean or a collection of values. In general, like y bar means add up all the y values, divide by the number of them you have, right? The average. How do you we know how to find like the average exam score, we know how to find an average homework score, but what's the average value of a function? The average or mean of a function f of x on an interval from a to b is given by f bar, which equals 1 over b minus a, all right, so that's the length of the interval, times the integral from a to b of f of x dx. But what is this, right? So we have this curve, this f of x. We want to know, like over this interval from a to b, what's the average height of this function? It turns out that it's right here at this line. So what we're really doing when we find an average value is we're taking this kind of a weird shape and we're making it into a box. All right, so average value, we can kind of see how things are going over a length of time. So let's find the average value of a function. F of x equals x cubed minus x over the interval from 0 to 1. We're going to plot the function and its average on the same graph, and I'm letting technology handle that. Okay, so first of all right, we have a and b, so we'll do our average is 1 over b minus a, the integral from a to b, so that's 1 over 1 minus 0, integral from 0 to 1 of x cubed minus x dx. Antiderivative of x cubed is x to the 4th over 4, minus sign. Antiderivative of x is x squared over 2. We'll evaluate that from 0 to 1. Notice 1 minus 0 is 1. 1 over 1, I just have a coefficient of 1. Kind of boring with this interval. Substitute 1, I'll get 1/4 minus 1/2. Substitute 0, I'll get 0. 1/4 minus 1/2, this is 2/4. 1 minus 2 is a negative 1/4. Notice here, our line is y equals a negative 1/4. And this is our graph, x squared minus x. Average value being right here. So if we were to make a rectangle of all this area, this would be the rectangle that would hold it. These pieces are equivalent to that piece. Equivalent in size. All right. So we also have a moving average. You know, as times change, we want to know if the stock market's going up, going down, what's happening with it. So an n-unit moving average, the n-unit moving average of of a function f is f bar is 1 over n, the integral from x minus n to x of f of t dt. Say what? Okay, so basically, right, if we have a table and we want a 3-unit moving average of the function, we'll have no outputs for the first 2 because we have to have at least 3. For the first 3 x values, I add up my r of x. 3 and 5 makes 8, plus 10 makes 18. 18 divided by 3 is 6. And then I'll use, I even have blue. I could do this. And then for this 6, I'll use these 3 values. 5, 10, and 3 add up to give me 18. Divided by 3 is 6. And then I'll use these 3 values. 10, 3, and 2. That's 15. 15 divided by 3 is 5. Notice the most recent 3 each time is what I'm adding up. 5 and 5 makes 10. 10 divided by 3 is 10/3. So our moving average shows us how the average goes along with every 3 units. But if we don't have a table, we do have this antiderivative we can find. Calculate the 5-unit moving average of f of x equals x cubed minus x. Plot the function and its moving average on the same graph, which I did not do. Bummer. So f bar of x is a 5-unit, so it's 1/5. I'm going to go back to my orange here. It stands out. A 5-unit graph, and we have our 1/5. The integral from x minus 5 to x of t cubed minus t. I know the function is x cubed minus x, but x is going to be our limits of integration, so we use t as our variable for the integration itself. Remember, it's a variable, it varies. I could use t, I could use ice, I could use popsicles in summer as my variable, but who wants to write all that? Okay, so the antiderivative of t cubed is t to the fourth over 4, minus antiderivative of t is t squared over 2. I still have my 1/5, and I'm evaluating from x minus 5 to x. So I'll substitute an x first, which I did. I left my 1/5 out in front. And then I subtracted what I got when I put in x minus 5. Okay, now, I have a 5, a 4, and a 2 as denominators. So what I did is I rewrote everything as a 20. Okay. So actually I wrote these as 1/4. So I'm going to call this 2/4. I'm going to call this 2/4. And now I'm factoring out a 1/4. I'll have x to the fourth. I'll have 2x squared. I factored out the fourth, so I'll have a minus x minus 1 to the fourth power. And if I factor out the fourth, I have a minus 2 times x minus 5 all squared. Now, this is algebra. We're in a class called calculus. So I let this computer just do this simplification for me. It turns out that, notice we're going to end up with x to the fourth here after we multiply x by x minus 5 by itself 4 times. So we'll have an x to the fourth minus x to the fourth. That's why the whole thing starts with the 20x cubed. So check it. Make sure I'm right. Distribute all of that out. Collect like terms. All right? And then we end up multiplying the 1/20th back through because we didn't want to deal with fractions. We could factor out the fractions. Here we go. X cubed minus 15x squared plus 24x minus 115. I'm going to pause this so I could bring up that graph for you. All right, so I got it in the window here for us. We can see our original function, x cubed minus x. Our moving averages function, all right, that's in blue. This is a much smoother curve than our original function, the moving averages. All right, I'm going to make that go away. We're coming back here. Didn't include it, but at least you got it in the video. All right. Annual production of ozone layer damaging Freon 22, which is known as chlorodiafluoromethane, in developing countries from 2000 to 2010 can be modeled by F of T equals 97.2 times 1.2 to the T million tons for T values between 0 and 10, right? Where T is the number of years since 2000. What was the average annual production over the period shown? Well, I know the average over the period from 0 to 10 will be 1 over 10 minus 0, the integral from 0 to 10 of 97.2 times 1.2 to the T dt. 97.2, that's just a coefficient. That just comes along for the ride. That 1/10 coming along for the ride. What's the antiderivative of b to the t? It happens to be b to the t divided by the natural log of b. So our b in this case is, our base is 1.20, so we have 97.2 still hanging out, the 1/10 hanging out, 1.20 to the t divided by the natural log of 1.20, evaluated from 0 to 10. Notice the only thing that changes here is this exponent. So we could even factor out, I would probably enter this in my calculator as that, and then I would do 1.20 to the 10th. 1.20 to the 0 power is 1. So I'd find this coefficient, and then I would find this value, and then I would multiply them together, and we get about 277 million tons was the average annual production of the Freon 22 over those years. Average, it got higher in some years. All right, suppose you have an envelope into which you put $3,000 at the beginning of each month. Banks, who needs them? You take out cash continuously so that the amount in the account decreases linearly to 0 by the end of the month. Find the average amount in the account over a period of several months. Assume that the account starts at $0 at t equals 0 months. Okay, so the amount that we have in the account decreases linearly. So for t values between 0 and 1, we'll take 3,000 to start, and we subtract out all 3,000 of that over time. All right, parts of it at a time. Okay, we're just looking at 1 month. From 0 to 1, our amount in the account is 3,000 minus 3,000 t dt. Take the antiderivative of 3,000, we get 3,000 t. Minus sign. Antiderivative of 3,000 t is 3,000 t squared over 2. 3,000 over 2 is 1,500. Notice when we evaluate at 1, I'll get 3,000 minus 1,500. And when we evaluate at 0, I'll get zeros. So 1,500. All right, each month it is depleted. So several months would all have the same average. If somebody asks, all right, you start your envelope with 3,000. If you don't look in it, on average you probably have $1,500 in there. No matter what time of the month you are, probably around an average. Now we know it won't be exactly that, but on average you have about half the money remaining at all times. Kind of cool. Moving averages compared to the actual function and what it does. Wow, my brain got stuck. Thanks for listening. 14.3 averages and moving averages.